Hello everyone, this is Dr. Sharif and today we are going to learn how to calculate reaction in this compound beam. For that beam, as we can see, we have two intermediate hinges at D and at E, and we know at the intermediate hinge there is no moment. Therefore, you can take a moment here for the right side, or you can take a moment or the left side and say it is 0, and the same for point at D. If you want to cut here, you know that you have two reactions, X and Y, and there is no moment. How many reactions do we have here? Let's check. You have a ruler support at C, so we have a ruler support here, so we can have a reaction called Y at C. We have again a ruler support at B, so we have one reaction which is called Y at B. And then we have a fixed support at A, and for fixed support, as you know, we have three unknowns. It will be Y at A, then we have X at A, and then we have moment M at A. Once we use the reactions, 1, 2, 3, 4, 5 reactions, so we need to solve and get these reactions. But before doing that, whenever you have uniform load or triangle load, it is better to get the resultant of each of those parts. So let's get the resultant of the first part, which is this one, the triangle that we have it here. Okay, for the triangle, we know that the area of the triangle equals the height times length times half. So 8 times 9 times half, let's do that. So 8 times 9 times 0.5 equals 36. Okay, and it will be at 1/3 from this height here. So let's say it will be somewhere here. And the value will be 36 kilonewton. And as you can see here, the distance will be 3 meters from this side and 6 meters in the other side. Therefore, again, this will be 3, and you have a 3 here. Now, we will do the same for the second area, or this uniform loading. We have here a uniform load with a height equals 8. So for that one, let's do the same. Okay, for uniform load, the resultant will be exactly at the middle. Okay, and how much it will be? It will be 8 times 6. 8 times 6 is 48 kilonewton. Okay, this is the resultant, this is the resultant. And the distance here will be at the middle of the 6. So this will give you 3 meters here and 3 meters on the other side. You have already 2 here, so the remaining here is 1 meter. And the last one is this one, this 6 kilonewton. Again, this is a third area. Okay, we can calculate the load from this area. It will be at the middle here. 6 times 2 equals 12 kilonewton. So this is 12, this is 48, and this is 36. And again, this will be at the middle here. So we have 1 meter and 1 meter. So we got all the resultants of the triangle, the first triangle, the second rectangle, the third rectangle, and we got the resultant. Where is the position of the resultant of each? Now we can start making our calculation using the 3 equilibrium equation to get the unknowns. And the easiest one to get is the x at A, because we don't have any other x in this problem. So by taking summation of forces in x direction, sigma fx equals to 0. Therefore, x at A equal to 0, and this is the first unknown, and it is easy to be calculated. Okay, so the x at A here equals to 0. Now we need to find all the other 4. YC, we can get YC by taking moment at the intermediate hinge here for this part. Okay, so if we take a moment here for this part, how many forces we have? We have a moment, we have YC multiplied by distance, we have 36 multiplied by distance, so the only unknown is the YC, we can get the YC. So let's take the moment here, so summation of moment about E for right part equals to 0. I assumed clockwise rotation is positive here. Therefore, let's make the equation. Then start by the 36. So 36 times 3 plus 48 kilonewton meter, which is the moment, minus, this is counterclockwise, so minus YC times 6 equals to 0. So a straightforward equation. From here we can get YC using calculator. So it will be 36 times 3 plus 48 all divided by 6. So it will be 26 kilonewton. And this is 26 kilonewton. And it is going upward as we assumed in our assumption. This is the second force that we can find. This is now 26 kilonewton. And before we have here x at a equal to 0. Now we found YC, we need to get YB. For YB, you can take a moment here for the all right side for this part, all D, B, E, C, and we can get the only unknown in this case, it will be the YB. It will be a long equation, but let's do it. The other option is to cut the beam into pieces and you get the reactions here and then transfer it to the other part and so on. I prefer not to cut the beam, just keep it close and take a moment for the right side, take a moment for the right side. Okay, so let's do that. We'll take a moment here for at D for the right side. So summation of moment at D, clockwise rotation, I assume it positive in this case, for right side, okay, equal to 0. And therefore, let's start. Now you have 48 kilonewton multiplied by this distance, which is 3. And this clockwise similar to the assumption. So it will be a positive. This is 48 times 3 meter. Okay, minus YB times 4 meters, which is this one. So minus YB, which is the unknown, times 4 meter. Then plus 36, which is this one, times the whole distance here, which is 4 plus 2. This is 6 plus 3 is 9. So 3 plus 2 plus 4. So it will be 36 times 9. Okay. What else we still have? We still have 48. Okay. This is again, so plus 48. This is a moment, not multiplied by any value. Then again, minus YC times its distance, YC times this distance until this point. So here you have 6 plus 6 equals 12 meters. So it will be minus 26, which is the YC, times 12, all equals to 0. By solving this equation, we can get the Y at B, and let's do it together. So it will be 48 times 3 plus 36 times 9 plus 48 minus 26 times 12 equal all divided by 4. So the Y at B equals to 51 kilonewton going upward as we assumed. And this will be our third reaction, which is the Y at B. And let's write it here as well. So this is 51 kilonewton, which is the Y at B. Now, once we got the Y at C and Y at B, we can take summation of forces in Y equals 0. So sigma Fy equal 0 for the whole beam. Therefore, Y at A, which we don't know, minus all forces that we have it here, 12, 48, 36, okay, or minus 12, minus 48 minus 36 plus the reactions YB plus YC, so plus YB, which is 51, plus YC, which is 26, equal to 0. And from here we have YA equals to what? Let's do that. It will be taken the other side by the negative, so 8, 36, 1, 26 equals 19. So the YA equals 19 kilonewton going upward, and this is the last vertical reaction, Y at A, and the value here is 19 kilonewton. Now, to get the moment at A, the easiest way is to just take a moment at intermediate hinge here for this part, for AB. So we take the moment at D for the left side. Let's do that. Summation of moment at D left equal to 0, and therefore here we assume the clockwise rotation is positive. We take a moment here, so YA is positive. YA is 19 times 2 meter, which is this value times 2 meter, minus MA minus 12 times 1. So minus MA minus 12 times 1 equal to 0. And from here we can get the M at A equals how much? Let's take the MA in the other side. So it will be 19 times 2 minus 12 equals 26. So the MA is 26 kilonewton meter, and the same directions that we assumed, and this would be our last reaction. So the value here is 26 kilonewton meter. Okay. Now we found all the reactions, but as I told you, always you have to make a check. Okay. So making a check, you need to take a moment at a point where you didn't take before. So we can take a moment at A for the whole structure. Okay, let's say summation of moment at A equals, and we see if it will be 0 or not. Clockwise, we assume it positive. Therefore, MA is counterclockwise, so it will be minus 26. The XA and YA are eliminated because we are taking moment here, so it is minus 26, then plus 12 times 1, plus 12 times 1, plus 48. Let's take all loads first. 48, which is this load, times this distance, it is 2 plus 3 equals 5, so times 5, plus 36, which is the third load that we have it here, times this distance, it is 2 plus 4, 6, plus 2, 8, plus 3 is 11, so times 11, okay, plus again 48 kilonewton meter, this is moment, and minus reactions, YB times 6 and YC times 12 plus 2 is 14. So minus YB, which is 51 times 6, minus YC 26 times the distance here is 6 meters plus 6 plus 2, it is 14. And let's check using the calculator if it will be 0 or not. So it is minus 26 plus 12 plus 48 times 5 plus 36 times 11 plus 48 minus 51 times 6 minus 26 times 14, all equals to 0. It means our solution is correct. Thank you for watching, and see you in a coming